have a look. On the top of the slide, on the left-hand side, we see Ohm's law, E equals I times R, and on the right-hand side, we see Watt's law, P equals I times E. We use those with series circuits, and they'll also work with the parallel circuits. Towards the bottom of the slide, though, are rules that only apply to the parallel part of the circuit. E total equals E1 equals E2. This is different than the series circuit. Now, if I knew that I had 100 volts at my source, I would also know from this formula that I would be able to use 100 volts at each one of the resistances. So 100 volts total equals 100 volts at E1 and 100 volts at E2. Let's say that I knew that each one of these resistors was 20 ohms. And if I knew that, I could go to the formula for finding R total. And what I've done is I've written that formula in two different ways down here on the right hand side of the slide. 1 over R total equals 1 over R1 plus 1 over R2, etc. Or R total equals brackets R1 to the negative 1 plus R2 to the negative 1, close brackets, to the negative 1. If I take my 20 ohms to the negative 1 plus another 20 ohms from R2 to the negative 1, close those brackets, and go negative 1, I punch that into my calculator, I will end up with 10 ohms as my R total. I can put that 10 ohms over here in my totals T, 100 divided by 10, and I can find that I have 10 amps. Now, one of the formulas for parallel circuits is I total equals I1 plus I2. And what that's trying to tell us is if we have 10 amps flowing out of the negative up through the ammeter called IT and hitting this junction or node, that 10 amps is going to split up. Some of it's going to go down R1, some of it's going to go out down R2. Now we could calculate out what that will be because we have two values in each one of our T's. So 100 volts divided by 20 ohms would give us 5 amps flowing down R1. And we also have the same flowing down branch 2. 100 volts divided by 20 ohms will give us 5 amps. Going back to this formula, if we have 5 amps in I1 and 5 amps in I2, then my total should be 10 amps. And when I look up here, I realize that I did have 10 amps as a total. So flowing into this junction was 10 amps, and then leaving that junction going to R2 was 5 amps, going to R1 was also 5 amps, and so you see that the rules for a parallel circuit actually work. I look forward to solving for Watt's law in the next slide.